easily communicate with our customers, easily be able to identify our customers' needs within the business environment. We understood that for you to be able to compete in an industry, there are certain forces, you understand, and so you need to develop strategies. So one of your strategies is using technology in every aspect of your business. And how do you use this technology? Which contains the details of your customers, that is your information, your customers transaction, as we did when we were discussing virtualness, and everything that we use the internet to link this thing, right? So as we are connected using the internet, how do you search for? We have about 4,000 customers. I'm just looking for 2 customers who did purchasing or who order with us last 2 months. How do I do that? As I go through all the records one after the other in order to look for them, how do I save these records of the customers or data of the customers on our system? You get it? So we need to create database that has to be to focus on each aspect of the business, each functional area of the. We can be able to have data about transactions and the activities that goes on within that sector, so we can be able to provide better services for our customers. So I gave you the slides to read, and I believe you have done that. So I'll ask some few questions, and then maybe you tell me what you have added, or when you met a group, what you did. Because I believe this week you've had your group discussions, and then you went through the slides, and then you tried to understand it better before we even have our class. Our tutorial. This is basically tutorial, so it's just about what you have learned and then what you can contribute or questions that we can ask, so that we can be able to go through it. If anybody can just tell us a little bit of what he or she did get for or from the slides. Yes, who is telling us something?
Um,
Yes.
okay, so the little I'll say about data management is okay. I know in some organizations some use Excel, some use softwares to organize their data. And um, me, I've been using Excel a lot to manage a lot of data at work. And the example that you just gave, that if you are searching for a supplier who, let's say, you supplied item to in the last 2 months, blah blah. If you have a huge data, it's it's difficult. Sometimes it's difficult to go through one by one and search. So you can also do, let's say, a summary page or a dashboard where you'll be able to just click, select a month, a day, or even the supplier name, and then you have the result in seconds rather than going through all the data in the Excel. So sometimes when we're using software, it is easy to just do click, and then you get the information. So data management in an organization is one key area that needs to be focused on in terms of audit and inspection and all that. It helps.
Thank you very much, Gabriel. Yes, who else can help us? What you have gathered so far? Yes, Festus.
All right. Um, Good morning, sir.
Good morning, sir.
My little contribution also. In today, in the world of technology, businesses cannot continue to go through or to transact its business using the traditional means of the traditional ways of doing things. And
Yes.
even with data management, it helps organizations to organize its information well for them to stay in competitive advantage to their competitors.
Yes.
So I realized that data management in today's dispensation would be one of the strategic tools for every entity. Thank you, sir.
Thank you very much. Yes, Dixon, then Frederica, then Suleimana.
All right, sir. Thank you for the
Thank you.
opportunity. Okay, so with the little that I got to know about the data management is that it's help you to align with your key performance indicator. That is, for instance, let's say I'm dealing with sales. With
Yes.
data management or with the customer that I have as my data management, it would be able to let me know how I'm performing in terms of sales. If I want to sort on, let's say, particular, want to know the sales performance of one particular customer out through the appropriate uh, um, application. So let's say Excel. If you want to see the performance of that particular customer, I just sort out and know what I have sold to him or the customer because I have these information about the person. And so if I'm selling, so that's whether I'm actually getting to my goal in as much my KPIs are concerned. So data management is very, very good in every organization that we have today. Thank you.
Thank you very much, Dixon. Yeah, Frederica.
Hello.
Yeah.
So, as a procurement officer, data-based management help us to record our orders, monitor our inventories, and track suppliers. If I take my hair business, for example, with the help of database management, I'm able to record my day-to-day sales, and record I'm able to draft contracts to send to suppliers, and I'm also able to okay, that's all, please.
Yeah. Beautiful. Beautiful. Wow. Yes, Suleimana.
Yes, sir. Thank you so much for the opportunity. Data is very key in a current business organization and industry. So it helps you keep all your documents, information, uh, employees record, your business transaction safer, not on a hard copy, so that at any point in time you need to refer. You just go as it is being well structured for easy reference. Number two, it helps you to monitor uh, your employee KPIs, appraisal system, uh, how to deal with business counterparts, real-time information sharing, and then it gives you just in time in ordering system so that it keeps you abreast with current trends, which of course you do that with less effort than going it the hard way through calling, visiting, and other old way of doing things. So in effect, data system makes it easy for quick reference about past year events that you have done, and then the future that you need, future information that you need to assist your organization in operation. Thank you, sir.
Thank you very much. Beautiful. Yes, Seraphim.
Um,
Yes.
please, I wanted to also ask if it enhances data security, maybe like it gives, like you can control who can have you can control who can have access to your data or like modify data. I wanted to know if you can say that.
Yes, it enhances security. Basically, when you have your database, for anyone to access the database, he or she needs a username and a password to be able to go into the database. And whenever someone goes into the database to make changes, you can go back to or you can check the back end of the system to know who made the changes and at what time the person made the change. So it guarantees a lot of security when it comes to the use of the database management system software to manage our database. So security is also one of the key aspects of the database management system or database in an organization. All right. So, all right. Thank you. So, looking at the explanation and stuff, you guys have a very good understanding of whatever that we're going to be doing or we are discussing. All right. That is basically it. So, database basically, or data management and modeling, they are very important or an important aspect of organizing data and information within every organization, whether it's a procurement unit, whether it's transport unit, whether it's within the banking sector or wherever that, or the military services or the police services. It is very, very important for us to be able to have well-organized data. So whenever we have a well-designed and then a well-managed database, it becomes the central of our information systems. It becomes the main or the pivotal point of our information system, and it helps us to be able to organize ourselves and then be able to make informed decisions or quick decisions within the business. And this database keep on increasing and evolving. Always IT specialists are coming up with different types of database that will help us to be able to organize and then mobilize our data within our data set. So why do we have to learn about database management systems and then data management? So databases capture data about changes within the business. So in the procurement sector, there are certain changes that occurred. The database will help you to be able to capture these changes. What are the changes for? Basically for analysis and decision making, to recognize new challenges and then opportunities within the business environment or within your business, to track progress toward meeting key goals. So when we capture this data within our database, it helps us to be able to track our progress towards achieving our goal. What is the goal, or what is the target for the year or for the next 5 years? The database will let us have a clear picture of where we are heading to and how we are going to get there. It also helps us to be able to identify when a change in tactics or strategy is needed. At what point do we need to bring a change? Do we need to change our strategies and our tactics? This will help us to be able to get that. So it is very, very important that we understand database systems and then data management. As you've all explained, that data management is very, very important to every organization today or to every business that we run today. And for us to understand basically our database, we need to understand the sources from which data or information comes from. And information or data can come from three main sources. First is what? Structured information. Right, structured information. That is one resources of information or data. So when we talk about structured data or structured information, basically we are talking about structured information that is well organized, that has some pattern, that there's an order. It follows an order. We move from 1 to 2 to 3 to 4 to 5 to 6. That is the pattern. And every organization relies on structured data or information, because without this structured information or data, you cannot make an informed decision. If you don't know 5, you don't have any information about 5, how do you make a decision about this? And so any information or data that is reasonably ordered, or there's an order and can be broken down into what component parts and organized into what hierarchy. So 1, 2, 3 in that order, A, B, C, D. So the moment you type in A, you know the information you're looking for. The moment you type in the index number, you know Dixon's name will pop up. That is the order. So example is our credit card or your student ID card. It contains information about you which is broken down into different, your index number, your name, your program you offer. So the moment we enter your index number, we can get every details about you in the university, whether you're a student, whether you're a registered student or non-registered student of the university. We should be able to get that kind of information. All right. So that is the first one, structured information or data, which is one of the resources. And then the next resources is what we call the unstructured data or information. So unstructured data, basically, as the name sounds, is data that is not organized. It has no inherent structure or order, and the parts cannot be easily linked together. So let's have an example. Example is what? A court case. You understand? For the court to have evidence, they need to gather several unstructured data from different sources. Some of these sources can be what? Phone calls of the person to the organization. For instance, what we use, Abu Traker's issue in Ghana here, I'm just using it as an example. For the court to be able to judge and say, oh, he's guilty or he's not guilty, they need to, so you can't just take a second to make a decision, because the data is coming from different angles. The conversation, his online chats, the links that he created, his phone calls, his personal life activities, his party. You need to gather all to see his personal businesses and all that. So you have to put them into different folders. The first folder contains his video calls. The second folder contains messages that he has sent. The third one contains information about whatever. So these are unstructured data or information, which sometimes takes a very long time for us to be able to come up with a decision and that. And then the last one is what? The semi-structured data or information. So when we talk about semi-structured data or information, it's basically data that falls in between the streams of structured and then unstructured. All right, so it has a little bit structured format and also a bit of what? Unstructured format. And that is what we term as the semi-structured data or information. And then we have what we call the metadata. So metadata basically is what? Data about data, and classify or group the nature or explains the nature of the information. So data describing data. A data describing the data. It has a clear definition. So in the context of our student records, so we have the field called your index number, another field called your first name, another field called your last name. So in the index, there are descriptions, something that describe what is in that field, and that is basically what we call the metadata. All right. So for structured data or information, metadata basically describes the definition of each field, as I was just explaining, or the table and then the relationships. So we'll be talking about fields, table, and then the relationships. All right. Then for the semi-structured and then unstructured data or information, metadata basically describe the properties of a document or other resources or the file. So each file has a file name, video messages, video calls, WhatsApp messages, emails, online. Each of these files will have a name. So we pick a file or the document and then we have the name. So that is the description of the property. Right. All right. Are we here?
Yes, sir, we are here.
Yes, sir, we are here.
Yes, sir.
Yes, sir, we are here, sir.
Okay, beautiful. All right, so now let's talk about the fundamentals of database. All right, so what is a database? Right, so we will try to define what the database is, and then why, as we have find out why we have to study database, because it helps us to be able to analyze our business patterns and stuff. So well-designed, organized, and then carefully managed collection of data or data is what we term as database. So we can define database as what? Well-designed, well-organized, and then carefully managed collection of data from different sources, from our customers, and from our customers demographic information, our customers transaction, our customers phone calls, whatever that goes on, we collect and then we organize it in a very good way so we can use for our decision. All right, should help an organization achieve its goals. So this will help us to be able to get to where we want to get to, and they can contribute to organizational success. A very good database can help us to be able to achieve our goals or achieve our target for the year or for the month. It provides managers and then decision makers with timely, accurate, and then relevant information built on data. So our database can always provide some kind of timely information for decision making, accurate information. We did speak about some of the characteristics of information. The information must be accurate, it must be timely, it must be current, it must be relevant, it must be consistent, it must be available, it must be understandable. These are all characteristics of information or good information. All right, so it can provide managers and then decision makers with timely and then accurate. Whenever you have a very good database system, it should be able to provide us with timely information, accurate information, and relevant information for decision making out of the data that we have collected. So most businesses or organizations use multiple databases, but we will be focusing more on one of the databases, right? So as I did mention earlier, the center of almost every information system is our database. That is the pivotal point or the cardinal point of every information system. Without a database, you will find it difficult to have an information system. What will be in that information system? You need information or you need data, and we use database to organize this data. So the most common type of database is the relational database. We have different types of database. We have the hierarchical database, we have the network database, we have multi-dimensional database, we have object-oriented database, and all that. So those are the data structures. All right. So the most common type of these structures is what we call the relational database, and that is what we are going to be focusing on for today. We are going to be focusing on the relational database, which is a two-dimensional database. It's a two-dimensional database, and then the variation of this type of information system is what we term as what the multi-dimensional database, right? Which organizes data in the form of cubes, and each cube contains several information or activities. So a relational database is a series of related tables that are stored together with a minimum of what duplication to achieve consistent and then control pool of what data. So when we have a database, as I said, a relational database, it's a two-dimensional database, right, which can be one-to-one relationship, one-to-many, many-to-many. So they are always two-dimensional. Right? Table A, table B, and there's a relationship between these two tables. That is the relational database. And they are organized in terms of what tables that are stored with minimum of what we are trying to reduce duplication. That Apple index number has been created 7 times by the 7 lecturers who are teaching you guys. I have created my own index number for all the students in this class. Dr. Nanajima Prempe has also created his own. Dr. Gifty Budu has also created her own. Dr. Afari has created his own. Everyone has created his own database to capture information about the customers. All right, so we try to use this relational database to have a unique identifier, which can be the index number, to identify all the students in the class, irrespective of the lecturer. We have a common identifier. All right. So some of the fundamental issues when it comes to relational database, as I said, this is basically theoretical. And next semester I'll be having the practical, so you guys can have a better understanding of all the things that, or the terms that we'll be using here to discuss or to explain our terms. All right. So some of the fundamental characteristics of
Say, please, your hand is
database.
up. Somebody's hand is up.
Okay, Suleimana, yes, please.
Yes, sir. Thank you,
Yes,
sir.
sir.
So, all we are discussing about database. So,
Yes.
I want to relate it to the family aspect of it.
Yes.
So, those married, if this data management system is like if giving birth to your child or children, there's in those days before internet and other stuff, they usually use hard copy. Some use board at a safer place in a room. Then they record the day the person was born before the event of baptismal card and then birth certificate. The day the person started school, the day they got married, the day they also gave birth, and all those collective stuffs. And then to some extent, the day some of the people, great-great-grandfathers passed. All this forms part of the database processing system. So as in relation to current trends, where we have the software that we can input with ease to keep record and keep the data safe for future generation. So in effect, database is a very critical aspect of our daily activities, and we must show keen interest in understanding and express our in-depth knowledge in it as we are being guided by your submission, sir. Thank you, sir.
All right, thank you very much. Yeah, so that is basically a practical example when it comes to database. All right. So the fundamental characteristics of what relational database. So data is basically, or data are basically organized into what? Relations. That's what I'm saying. There's a relationship between the father, the mother, and then the children. All right. In a home, there's always a relationship between the two. So rows represent entities and columns represent attributes. So in every database, whenever you see rows, it means we are talking about what? Entities or tables. And then the columns represent attributes or fields. All right, so the rows, which is the table or the entities, uniquely identified by a primary key. So every table or in a database table, there must be what we call a primary key, which is a unique identifier. Something that can uniquely identify this person as a staff, as a student, as a passenger, as whatever within the database. Right, so for students, the unique identifier of every student in this school is basically your student number. So mostly the primary keys are numbers. Most of the time, primary keys are numbers or combination of numbers and alphabet, which is alphanumeric. All right. So columns. All right. And then we can use what? Integers, decimal numbers, date, text, etc. to describe any of the columns in a table. All right. So the field within our table, it can either be numbers, integers numbers, or alphanumeric, or decimal numbers, or date, or text, or whichever that we want to use, based on or depending on whether it's going to be a name, or it's going to be numbers, or it's going to be a date or time. We can select that kind of character. They are constrained to be certain type, length, or to have a value between two limits. All right. So it can easily be constrained to what? The type. Which type of field is this? Is it numbers? Is it supposed to be numbers? Is it supposed to be alphabet? What is the size? Is it supposed to be 10? Is it supposed to be 100? Is it supposed to be 225? Or supposed to be just 7 or 6? So we can give the length, and then we can have, so that is basically what will be described in the field. All right. So primary key and then foreign keys enable table relationships. So we'll talk about primary keys and then foreign key. A primary key in table A, when it moves into table A, or when it's posted into table B, it becomes a foreign key. All right, in that table. And the user queries perform operations on the data. So we can perform some queries. We can question the database to give us certain information that we are looking for. So in this class, I'm just looking for this index number. Index number 2572837247. Then I just type it in. The database will give me the information or whatever I'm looking for. So it helps us to question the database using the query languages and stuff. It gives us a clear indication what we are looking for, what we want to have, and all that. So a relational database is made up of what? Number of what? Tables. Right. So as I said, we want to break it down into the hierarchies from the lowest to the highest, or from the highest to the lowest. right? So every database is made up of what? Tables, combination of tables. So if we pick a table, we can have a table of procurement student level 100, or procurement and logistics and then supply chain student, transport student, table of all transport students, all procurement students, and then table of maybe accounting students, those who are offering accounting, table that contains details of all IT students level 100, diploma, degree, and all that. So that is basically table. And when we combine these several tables, it forms our database, where we are able to link all these tables to have records of all level 100 students, distance students level 100, 2026. That becomes our database. All right, because we are combining several tables together. And within the tables, what components forms the table? So if you pick a table of students in your class, right, it's made up of records of every student in the class. So records of Serafina, records of Gabriel, records of Sulemana, records of Dixon, records of Joseph. That has come together to form the table of all procurement students, level 100 distance. Do you get it? And these records are also made up of what? Fields. So let's pick records of Gabriel. When we pick the records of Gabriel, it's made up of what? Different fields. The field called index number, another field called first name of Gabriel, another field called last name or surname, another field called gender, which is either male or female, another field called program or courses that he's offering, so the course is stated, another field called address, then we can even have date of birth and all that. Those are the fields. So each person in that table has his records, and the records is made up of different fields that comes together to form this record. And then in the field which contains, let's see, Gabriel, which is the first name, the field called Gabriel or first name Gabriel, this field is made up of several characters, right? We have combined Gabriel to form the first field called name. So fields are also made up of what? Collection of what? Number of characters. All right. The character can also be called a byte. So one byte or one character is made up of what? 8 bits. So the 8 bits are in zeros and ones. So when we combine 8 zeros and ones, we can form the alphabet J. Then when we combine another 8 zeros and ones, we can form the alphabet or character A, and then B, and then R, and then I, and then E, and then L to become a field. So characters form a field, and then characters are made up of what? A combination of what? 8 zeros and 1, which is called bits. So 8 bits is made becomes a byte, and then several bytes or characters becomes a field, and then several fields becomes a record, and then several records becomes a table, and then several tables becomes a database. Are we getting the breakdown? So from the smallest, so from the smallest, all right, from the smallest, it's 8 zeros and ones, which is called bits. So we can have maybe, I don't know if you guys remember when you were in high school, you did number bases. So if you want to convert some numbers to maybe 2 decimal or 8 decimal or 10 decimal or decimal, So you can have the numbers maybe 0, 1, 1, 1, 0, 0, 1. They have to raise it to the power. So the first one is raised to the power 0, raised to the power 1, raised to the power 2, raised to the power 3, raised to the power 4. I don't know if you remember that. Those are binaries, right? So it's zeros and ones, which is just two digits, 0 and then 1. So if you combine two zeros and ones together, then we are forming what we call a character or a byte, and that zeros and ones are called bits. So 8 bits is equal to 1 character, which can be A, which can be 1, which can be 6, which can be 8, which can be 7, which can be 4, or B, or C, or S, or L, or whatever, a character. And then when we combine characters, we can form a name or an index number. And that name is called what? Maybe a first name. So the field is called first name, or that field is called last name, or that field can be called date of birth. It is made up of different characters, right? And then when we combine several fields, we form what we call a record. And then when we combine records, it becomes a table or a file. And then this file, when we combine several files of several tables, it becomes what we call what? Database. So these are the hierarchy I've explained. When we go further, we will see that in the right. So each record is made up of what number of what fields. The fields are the specific items of data stored about an entity. A field can be called a field called first name, last name, date of birth, address. These are all fields. Right? When we combine them, we can have records of a person. When you are given a form, they ask you to fill this form with your details. So that becomes your records. So the first part is your name. So first name. The second part is what? Your surname. The next part is what? Your date of birth. These are fields. So when we combine them, it becomes, when you are done filling the form, it becomes records of you. And that record is made up of several different fields that has come together. All right. So address, etc., that is entity, or something of interest to the firm known as an entity. Right. So entity can be a name of a person, it can be a place, it can be a thing that is of interest to the organization. So a customer is something that is of interest to the organization. Student is something that is of interest to an employee is something that is interest to the organization. All right. So that is called an entity, which is records. And then the entity has attributes, which are the fields that describe the entity. So record collects all the data about one specific entity, the customer called Prince Kelvin, for example. All right. So record of me in the school is a lecturer. Is this all the information or the records or the fields about me that comes together to describe who I am in the school. All right, so I've explained this: record, field, file, database, and that is it. So the hierarchy of data, it starts from what? Bits. I've explained bits, which is zeros and ones. So 8 zeros and ones. Yes, Hassan, Jonathan.
Good
Yes,
afternoon. Please, I want to find out this thing. You were talking about the bits. Yeah, and then I don't know. So like the several bits form the character or the fields. I want clarification on that.
8 bits forms a character.
Okay.
Yes, and then several characters form a field.
Okay. Yes, sir. Thank you very much.
Yes. So when you combine 8 zeros and ones, it forms one character, which is called A. Then when you combine another 8 zeros and ones, it forms a character called H. C, B, 1, 2. So when we combine these characters, it forms a field. And then when we combine fields, it forms records. And then when we combine records, it forms a file or a table. And then the table leads us into what? A database. So have you seen the hierarchy from bit, character, fields, records, files, or tables, and then database? Are we all here?
Yes, sir.
All right. So please,
Yes, sir.
is the explanation clear now? That for us to have a database, it has to start from the atomicity of our data, from the minute of our data. Then we have to combine them gradually. Then it becomes just like building a house. You have to start from digging the foundation, casting concrete, laying the blocks, roofing, and then painting, plastering, painting, then organizing the interior, and then now it becomes a house. That becomes the database. So it has to start from somewhere. And then gradually we move to where we have to be. Right, so this is a typical example of the hierarchy of data. So characters, which is made up of, or character which is made up, can you see the 8 zeros and 1s here, which forms the letter F or K or C or whatever? Can you see? So this is bits, the zeros and 1s here. It's a bit, and they form a character. And then the characters will move on to form a field called first name, which is the person's name there, you can see, or last name field. And then the records is what? The person's first name, last name, address, whatever, coming together, which contains what? Records containing the SNIT number, the last, and then first name, date the person was hired. That's the records of one person within an organization. And then when we combine several records, we can have a file or a table which is made up of several employees within the organization. So personnel file, which contains several employees of the company. And then when we combine different departments, personal file, different departments, and then the payroll files together, we can have a database. So when we go into the database, it contains several activities and several things within the database. All right. Are we here?
We are here, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir, we are here.
All clear, all clear.
All right. So I've explained entity. We all know entity. Entity can be a person, a place, or thing, or something that is of value to the organization, or a thing for which data is collected. A customer, a shop, a school, a bank, a hospital, an employee, a student. These are all things that we collect data about, store the data, and then maintain the data. That's an entity. So it is very, very important that whenever you are working in database, you are able to identify all the entities within the database. You get it? And then the attribute, the characteristics of an entity. So the fields are the attributes. And then the data item, the specific value of an attribute. So what's the value? Is it the first name, the last name, the address, and all that? Those are the data item within that attribute, or describing the attribute. Then the primary key, a field or set of fields that uniquely identifies the records. I have explained this, that in every table there must be a primary key. So the primary key uniquely identifies whoever is within that table. All right, so let's go on. We'll explain more about the primary key. So as I said, primary keys are mostly numbers. So if we take an employee within an organization, what can be used to identify the employee within the organization? So for instance, myself as a lecturer of GCTU or as a staff of JTU, so what can be used to identify me as a staff of GCTU?
Sir, your staff ID.
So
Staff ID. Beautiful. Yeah, Suleiman, you also have something to say.
Yes, sir. Yeah, exactly what they've mentioned. Your staff ID, sir.
Yes. Yeah. So if you're a police officer, what can be used to identify you?
Service number.
Your service
UCD.
ID card.
Service number or service ID. Yes.
Yeah.
As a student, what can be used to identify you?
Then
Student ID and index number.
number.
Yes. So your student ID or your student index.
Index
So
number.
that is basically your primary key. You understand? A unique identifier. Something that can uniquely be used to identify you. So employee has employee number. So in every database, the primary key is something that can be used. Your name cannot be used to identify you. You understand? A doctor has a number. Even when you go to shop and then you purchase item, they don't use your name. They use the purchase order or the order number. If you buy food from KFC, they give you a paper and it has an order number. So the moment you mention the number, that is the unique number to identify you who bought this and the time the person bought the item. Right. That is it. So that is the primary key. So if we will talk about that. So here you can see there are two numbers here. We have the employee number and then we have the department number. You understand? So the department number in another table, in the department table, that will be the primary key. But in this table, we are talking about the employee. We are describing the employee. So the department, because the employee must belong to a department, right? That is why we have the department number here. So the department number here has become a foreign key in this table. But when we have another table that contains the department, that has information about the department, then we will have the department number, the department name, the department description, department location, and then the unique or identifier will be the department number. But this has been moved from that table into this table, so it has become a foreign key in this table. Right, so that is basically, so here in this table we have the employee number as the primary key. If we have another table called the department table, where we can also have the employee number on that table because the employee must belong to a department, then the employee number will become a foreign key in that table. All right, so that's the difference between a primary key and a foreign key. So a primary key is a field in a table that is unique. Each record in that table has a different value in the primary key field. All right, so the numbers are not the same. Your index numbers are not the same. Your staff numbers are not the same. That is what we are trying to say here. So the primary key is used to uniquely identify each record and then to create relationship between tables. Student number or student ID, exam ID, the library ID, staff ID or employee ID, order ID or order number. These are all primary keys that uniquely identify the person. So primary keys are used to join tables. So when a primary key is posted or is copied into another table to join the two tables, then that becomes a foreign key. So let's check in the table here. So here we have a customer table and then the order table. So in the customer table, what's the unique identifier here?
What is that?
What? In the customer table,
The customer number.
the customer number is the unique identifier. And then in the order table, what's the unique identifier or the primary key?
Order number.
The order number.
The order number. Beautiful. All right. So how do we link these two tables together? So when we check the first table, we have customer number, first name, surname or last name, address 1, address 2. Let's check the second table. We have the order number, we have the description, we have the primary key, the price, the color, and then the customer number. Right. So now tell me the two tables, what do you see? Is there any relationship? Can there be a relationship between the two tables and why?
So there's a relationship
How?
because the customer table, from the customer table, we've realized that the customer numbers have been also brought and attributed to the transactions at the order table, which means that, for instance, at the order number under the order table, the first 100, and then we have the customer number 10, which means that number is what attributed to the Jane Wilson.
Jane Wilson, yes.
Yes,
All
sir.
right. Yes. So basically, in these two tables, the first table, which is table 1, the customer number is the primary key. But in table 2, we have the customer number there again. So what has that become? In table 1, it is the primary key there. In table 2, what is its position?
Is it in the entity?
No. I just described this.
Okay. Primary key.
So in table 1, it's a primary key. So when it moves into table 2, it becomes what?
It's a foreign item.
Yes, so it becomes a foreign key.
Okay.
Right.
Okay.
So when a table has a primary key and then that primary key is copied or pushed into another table, it becomes a foreign key. Are we getting it?
Yes, sir.
Yes, sir.
And there can be relationship when a primary key becomes a foreign key in another table. Then there can be a relationship. So here what we are trying to say is that there are customers and then there's an order. So there's a relationship between a customer and then an order. Because if a customer doesn't place an order, then there's no order. A customer must place an order for a relationship to begin to take place. I hope you are getting it. So now we can combine these two tables to become just one table with a customer and then the orders that they placed nicely. The price of each order, the description of each order, and everything. We can combine it to have a bigger table. All right, so we can go on. So a foreign key, I've described that. All right. So a foreign key, when a primary key is posted or is copied into another table to create a relationship between the two, it is known as what, a foreign key. That is what I just described there. And then we have what we call the referential integrity. It means you cannot have an instance of a foreign key before it exists as an instance of a primary key. So in these two tables, we cannot have the customer number in this table without having it in another table as a primary key. For instance, if we were to have this table, right, the customer table without the customer number, then the customer number cannot exist in the order table. It cannot appear in the order table first before it will appear in the customer table. It has to be in the customer table first as a primary key before it becomes a foreign key. All right, that is what we call the referential integrity. So if, for instance, you want to create a relationship and there's no primary key in table A, but you have created that as a foreign key in table B, there can be a relationship. So always whenever you are working in database, you have to enforce referential integrity. You have to enforce that to ensure there's a relationship between table A and table B. Yes, Suleimana.
Yes, sir. Sir, please, I want to refer to the tables. If
All right,
you
so
can
let's
go
go
on,
back.
sir.
Yeah.
So the first table, the customer table, and then the order table. So a careful look at the two tables when you merge them. You can have a comprehensive outprint of whatever transaction is being going on, where you have the customer number, the name, first name, second name, address 1, address 2. Then you get a description of the item. the price, the color, and then other remarks in that order, which will give you a final printout of whatever transaction can go on, if that is what will be the end result, sir.
Yes, yes, definitely. So that is combining or joining the two tables to form a bigger table, or to have one bigger table for your transaction or your activity. So creating relationship prevents the data from being stored in both tables, as Suleiman was describing. So the moment we decide to join the tables, now we prevent having the customer number here, the customer number also in another table. The moment we join them, the customer number will appear once in the big table, and the order number also appear once in the big table. So we prevent repeating numbers and stuff in our table. All right, so that is it. So this is a typical example here. So who can help us to identify the primary keys and then the foreign keys in these tables? Help us. So we have table 1, table 2, table 3. So if you can start with table 1, the primary key is this. Table 2, the primary key is that. And then table 3. So in table 3, we have the SSN, which is the staff SNP number. And then table 2, we have the department. It is called the department number. And then table 1, we have the project, which is called the project number. So tell us, anybody can tell us the primary key in each of the tables, and then afterwards tell us the foreign key. Somebody can also tell us the foreign keys in each of the tables.
Okay, so the project table is the primary key.
All right, in table 1.
Yes, table 1.
Okay.
Okay, and then the table 2, the primary key becomes the manager SSN.
In table what?
In table 2.
Table 2.
Yes, sir.
The what? The foreign key or the primary key?
The primary key.
In table 2, which is the department table.
Yes, the SSN.
The SSN. Okay.
Yes, sir.
Okay. And then in table 3?
In table 3, it becomes a foreign key. It becomes a foreign key.
Okay.
At that is in the same place as the SSN there.
The SSN. Okay.
Yes, sir.
Okay.
I think it's still primary key.
Okay.
Oh.
So give a share your view. We are debating, so anybody can share his or her view here. So table 1, we say the project number is the primary key. And table 2, which is the department table, what's the primary key? So Hassan believes the manager SNP number is the primary key. Yes, if it was.
Sir.
Yes, madam.
Sir, please. I think the table 1, the primary key is the project number.
Okay.
The table 2, the primary key is the department number.
Beautiful.
And the table 3, the foreign key. The foreign key is the department number.
Okay. So what becomes the primary key?
In the table 3 is the SSN.
SSN. Beautiful. Beautiful.
Okay, sir.
Yes, sir.
Yes, I have seen something. That's so now maybe the reason why I have to also clarify myself is that now the table 3 is about what? The management table. So meaning that basically the primary key will be the SSN.
Yes, because it's describing the manager.
Yes.
It's describing the describable trait describes the manager.
And then so if it is that is in the primary key here, then it becomes a foreign key that is in the department table.
Yes.
Yes, sir.
Yes. Beautiful. So in table 1, the primary key is the project number. The foreign key is the department number. In table 2, the department number becomes the primary key, and then the manager's SSN is the foreign key, and then in table 3, the manager's SSN is the primary key, and then the department number is the foreign key. So here, is there any relationship between any of the tables? If you can check through the tables and let us know.
Yes, sir. The table 2 and then the table 3.
So table 2 and table 3, there's a relationship, so we can join table 2 and table 3 together to form one big table. So now if we join, now we have one big table which has the department number, the manager's SNIT number, the manager. So we can start with the manager's SNIT number, the manager's first name, the manager's last name, the department number, the department name, the date height in that table to form one big table. And then now let's check table 1 also. Is there a relationship between table 1 and any of the either table 3 or table 2?
Yes, sir.
Yes. So now we can join table 1 and table 2 also. So yes, Osman.
Oh no, Sen, I want to answer the question, but Hassan has done that.
All right, thank you very much. So now you can see we can merge these 3 tables together to form a bigger table. So here, these are the tables and their colors. So when we merge them, we can have this big table here, which is the 3 tables with the 3 different colors: blue, ash, and then whatever, the green or lemon green. So these are the 3 tables. So you can have the blue here, we have the ash or whichever color, or brown, and then the lemon green, and then we have joined the 3 tables to form one big table. So that is basically, yes. Fidaus, is your hand still up?
Yes, sir. Sir, please, a question, sir.
Yes, madam.
Sir, please, does it mean that in every table, the foreign number is almost at the end part and the primary
probably
number?
That is how it's supposed to be, but it can be mixed up. But mostly the primary key is supposed to be the first, and then the foreign key, which is, because it's not just like a foreigner, you're always supposed to be hiding at the back of the, you are not supposed to be in the middle of the meeting, but you should be at the corner there to monitor what's happening. You understand? So mostly that's how it's supposed to be, but it can be mixed up. It doesn't matter, but that is basically, in a logical sense, that is how it's supposed to be.
Yes, sir.
The primary key first, and then the foreign key will be at the end. Yeah, Suleiman.
Yes, sir. So a careful look at the table. The primary key is easily identified by the description on the table, the description item before the tables.
Yes. So for instance, if it's a student table, you will see student table, and then the first thing will be student number.
Yes, sir.
Yes. Customer table, the first thing will be customer number.
Yes, sir.
Yes. So basically, you just have to look at the heading, and then you can just be able to identify which one is supposed to be the primary key and whatever. All right. So the database approach. Right. So before database came up, there was what we call the file processing system. The file processing system basically is a type of records management system where each department created their own means of what? Keeping records of the customers or the transaction that goes on within the department. So each department will have their own software that they use at the department to create the records. And then they have their own means of what? Identifying the transaction that took place within their department. You get it? So at the end of the day, GCTU, each department is creating their own software or have their own software that they use, and then how to manage the software and stuff. when we want to merge all the activities together on one platform or one common center, it becomes difficult because the software accounting department use is different from the software the procurement unit is using and the software the economic students are using and stuff. So integrating the records together becomes a challenge. So there were a lot of issues. Integrity of the records, is it available? The availability was a challenge. This was an issue. This was this was that. Several things happening. And therefore there was a need to have a common platform or approach which can help the organization to be able to merge whatever that has been done from different angles together, so we can be able to perform our functions or our duties. Right, so, and that is when the database management approach came in. So the database management approach came in to improve strategic use of corporate data and also to reduce data redundancy, because each department depends on what has been created, which is the unique identifier. We don't have to create different records about our employees or customers. And then improve data integrity, easier modification and update. We can always go back to our database and then modify and make a change in the database. All right, data and then program independence. So all the data that we use or whatever data or program that we use are dependent on what the software that is used to run the database. So it doesn't matter whatever type of program you are using, it has to work. The database is able to work with it. So we don't have to force ourselves and say, oh, this one is not working here. It will link up in the database. Better access to data and information within the organization database, and then standardization of data, a framework for program development, better overall protection of, as what's the name of the lady Ramatu said was asking. So security, protection of the data within the database, and then share data and information resources across the database. So some of the disadvantages of also using database, it is more complex. So you need you need professionals to work with the database, not any ordinary person, but you need people who are skillful, who are professional, who are skilled to work with the database, and that comes with a lot of challenges. So whenever you are working in the database management system software, many decisions are to be taken, right, which needs people with more experience and stuff. More difficult to recover from a failure. When the system fails, it is very difficult sometimes to be able to recover or to get your records back. When the system shuts down, you might end up losing everything. That is why you always need to have backup, another database of the records or of the data we have at a different center, so we can be able to protect the records. More expensive. So if you don't have money, you can't run a database because it's expensive to use the SQL database and stuff for your business activities. Right, so some of the disadvantages. So a database design is also known as what? Data model or database schema. So this is a typical example of a data model or a schema. So a customer, right? We have a customer. So we have the customer number, the first name, the surname, the telephone number of the customer. Right, the order, we have the order number, the description, the price, just like the table that we have, or we had this table. Where is it? This one, the customer, and then so in the schema, this is how it's supposed to look like, breaking it down into the different components: supplier number, the company name, the contact, the first name, the contact of the person, the surname, the telephone number. That is basically it in that sense. So it's a list of all the tables in the database along with all the fields with any primary and foreign keys identified. So in this instance, you need to be able to identify the foreign keys. That's why we have the number attached to it, the number or the symbol attached to it. So we are trying to identify the primary key. In a normal table, we will have a normal key, the symbol of a key attached to the primary key to indicate that that is the primary key. All right. So designing relational database. One approach to database design has 4 main stages or steps. The first one is it's very important to identify all entities. All right. In a database, you need to be able to identify all the entities and then be able to list them down. If there are 7 entities, you need to be able to list them down. Then identify all the relationship between the entities. So the entities, what are the relationship between all the 7 entities that you have identified? You need to be able to have that. Then the third one is identify all attributes. So what are the attributes of these entities, or what are the fields for each of these records that you have identified in your database? Then resolve all relationships. So afterwards, they have to be able to resolve the relationship between all the entities and then the attributes. So the first 3 stages are performed by what? For example, interviewing staff, so managers and then users, observing staff at work and then reviewing existing documentation. Relationship between entities are governed by what? The enterprise or the business rules. So resolving a relationship means deciding how to implement this relationship. Which primary key will be used as a foreign key? You need to be able to know that you can be able to work on, or whether to use a linking table, like there's table A, table B, and then you can link the 2 tables to form one table by selecting some fields or some records within the table. So once you identify a relationship, there are 3 things that you need to always consider, or you always need to have it in mind. And that is what? And then document them down. That is the degree, the cardinality, and then the optionality. All right. So when we talk about degree in any database, we are trying to talk about the number of entities involved in a relationship. As we did mention, that you need to be able to identify all the relationship, all the entities. So that is the degree in our database term. So in the database, the degree of what. Then we are trying to let you know the relation, the entities that are involved in the database. All right. And then the cardinality in a relationship. Cardinality is the what? Number of one entity that can be related to another entity. So that is it. So is it one-to-one relationship? Is it one-to-many relationship? Or is it one-to-many relationship? Right, so the number of times that it can go in, so one-to-one relationship, one-to-many relationship. Yeah, Hassan.
Sir,
Yes,
I
sir.
want to know the cardinality. Is it in a relationship? Cardinality is the number of one entity. The number of one entity that can be what? Related to another entity. And that one entity is because it's talking about a number, meaning that a certain kind of entity in a certain number of or in a certain number. So can you please explain that one further to me?
Yeah, so the number of one entity that can be related to another entity. Yeah, so this entity, how is it related to this entity? Is it one-to-one relationship between them, or it's one-to-many relationship between them, or what is the relationship between these 2 entities. So this is the first entity, which is maybe a customer. What functionalities or what activity can this customer do? Is it the customer to many purchases, which is one customer to many purchases or many order, or just one customer purchasing one item only? You understand? So it
Yes,
is
sir.
a customer, and then the relationship that exists between the customer and the things that he or she is performing. So a student, as you, is it a student to one course or a student to 7 courses? So a student has many courses, so one to many relationship. And there can be a student to just one course, a student taking only mathematics for this first semester. So one-to-one relationship. So that is basically one entity that can be related to another entity. All right. So the entity can be a course, which is also an entity. So is it just one course or many courses? Which is, in any case, is also an entity, but has several branches. And then optionality is basically if a binary relationship is optional for an entity, that entity does not have to be related to the other. All right. So if it's optional, then it means it must not have any much relationship or any relationship with you, the customer. All right. So a customer can place an order, or may place an order, or may not place an order at all. So if the customer decide not to place an order, there's no relationship between the customer and then the orders that were placed. So we are all going for lunch, then somebody is going to buy food. So we can send people, oh, buy me this, buy me that. As somebody is going, oh, buy me water. You are placing an order. Somebody in the class can also choose not to place an order at all. So it's optional whether to buy something at this time or not to buy. It's optional. It's not by force. I hope you get it. So that is the optionality of our database. So we'll have some examples quickly, and then we'll end our meeting for today. Then we'll continue next week. All right. So the rules. So let's talk about the rules. The rules governing relationships between entities. All right. So each order must be placed by one and only one customer. Right. And then each customer can place many orders, one to many. But some won't have placed any order at all. So it's optional. So let's look at the symbols here. You can see after the customer, you can see there's one. Can you see one written there?
Yes, sir.
Yes. And then at the other end, which is the order, there's 0. Some 0 symbol there. And then there's this 3 or 1113, which is called the crown's feet. So the crown's feet represent many. The 0 represents optional. And then the 1 represents one and only one activity. I hope you are getting it.
Yes, sir.
Yes, sir.
Yes, so let's read the description again. So each order must be placed by one and only one customer. That's why we have the 1 here. So the order was placed by one and only one customer. So we know who placed the order. It's only one person. And then the next one is what? Each customer can place many orders. So yes, Jonathan.
So, sir, that's to say that even if it's a company, Krampuna, the company's name is the one that becomes the customer in the order.
Yes.
Yes, sir.
Yeah, so we are just using a customer to represent either the full company. So a company can also become a customer to a different company, basically. All right. So each customer can place many orders. That is why we have the crown's feet. Many. So many order has been placed by a customer. But some won't have placed any order. So some customers might also decide not to place an order. That's why we have the 0 here. representing that. And then here we have the supplier, we have the product. So here we can say each product must be placed or must be supplied by one and only one supplier. So each product can be supplied by one and only one supplier. That's why we have the one here. And then one supplier, a supplier can supply one and only one product. You understand? Supplier can place one and only one product. Or supplier can supply many products. That's why we have the one to many, and then we have the one to one relationship. So that is how the cardinalities work. It's either he's having an activity at a point in time, many or one, or nothing at all happening, which is the optional. So let's check the other one as well. Employee and then passport. So who can, okay, I've already described. So who can, in your own term, describe what this means?
So it means that a single employee is also supposed to be entitled to a single passport.
Yes. So one employee entitled to one passport, right? And one passport can only belong to one and only one employee of an organization. All right, so that is basically one to one. That's why we have the one here and then the one there. Then we have one to one relationship, optional on one side. All right, so let's see, employee and then company car. So each employee might have 0 or only one company car. That's why we have employee one car belongs to an employee, or you might not have a car at all, right? Each company car is allocated to one and only one employee. That's why we have only one here. So the company car is basically what? Assigned to one and only one employee. So that is the relationship between. So in essence, we can have symbols like this, and then you have to identify what it is. Is it one and only one? So here, who can describe this based on what we have done? So we have employee, and then we have a laptop. Yes, Suleimana.
Sir, please, the previous slide, I want to.
If you come back here.
So this one is one employee, one or 0 cars. So in the situation where the vehicle is like in a transport pool where they use it for official duties, how do we relate that?
Yes, at a point, you are only allocated to one car at a point. I hope you get it. That no matter the number of cars you drive, but at each point you are allocated only one car.
Yes, sir. Yes, sir.
Yes. So that is how it's going to be. Yeah. Okay. Yes. So who can tell us? Employee and the laptop. Then we have 1 here, 0 here, 1 here, 0 here. What is the explanation?
So it's trying to say one employee can either get one laptop or none. So you can be sometimes in a working environment, it's not all the employees that uses laptop.
Yeah.
So they can assign one to you or not. The same as a laptop, 1 to employee or 0.
0. So that's why we are using the might. So each employee might have one laptop. You understand? Each employee might belong to one, or each laptop might belong to one employee. But some are for general use and therefore won't belong to anyone at all. So that's why we have the 1 here and then 0 here. So there are some employees who will not have laptops to themselves. And then there are some laptops which might not belong to anybody as a staff in the company. It's for general purpose, so it does not belong to you. If I come, just like the office laptop, open laptop in the office, everybody can use the laptop. It doesn't belong to you or whatever. It's open to us all to use the laptop for our work. All right. And then here, customer, and then so who can tell us in your own view?
Customer can create one. Like customer can create many, zero or many
So he
others.
can place many or no order at all.
No others.
Yeah. So in a shop, you can decide to buy many items at a point, or buy nothing at all. You just go for window shopping and then go home. And then order can be placed by one and only one customer at a time. Because when you go to KFC, the order number belongs to only one person. You cannot mention order 7 to 8, then 10 people are up. Because this order, no. It has to belong to only one person at a point in time. All right, so that is it. The next one is what? Student, teacher, or student courses. So what's the relationship? Who can tell us the cardinalities?
It means, are we using elective or teacher?
That's why the symbol belongs to each side. So we are using all. We are using both elective, and so elective is courses.
Okay, so a student can be assigned to one elective or none.
Yeah.
But the elective can be assigned to
take either one elective or can decide not to take any elective at all. That is it. Yeah. Can take one elective or no elective at all. And then, what about the student? Elective can be taken by many
students or none.
Or none. Right. So that is how the description. Please, my ladies, are they here? It's when it gets to a point where the ladies are not talking.
Please, we are here.
So, sir.
Here, there you can be, but.
Yeah, please. So, reference this particular one that you are saying that a student can take one elective, no?
Yes.
That reference your portal where we registered our courses. Can this one also apply to that place that you can take a subject that you want to master or you want to be taught about, or with that one is composed, you need to pick all subjects provided?
Yeah, for your courses, it's all compulsory. You see, at the university level, they are compulsory. But you see, some universities, they have some optional courses. If you want to go to another department, we don't have it here, but like University of Ghana like this, you may be information system student, but sometimes you want to go to geography and then pick a course. So those are optional. You can just add those courses to whatever you are offering to. So that is where you choose just one out of all the courses. You see, and then add it to whatever you are studying to help you boost your credit points.
Yes, sir.
Yes. Yeah, someone was also where is my ladies, who again do I know? I only know Fida was, and then Serafina. Who else? Where are my military ladies? Where are they? Yes, Suleimana.
Yes, sir.
Yes.
Sir. So from the student point, you see the 3 arrows. Can it also be that many students from, let's say, different faculties pursuing one elective course? That is to say, logistics and transport, HR, engineering, will all be doing one course, will come together and do one course, if that is going to say.
Yeah, so in this description, we can have, so many students offering many courses. then you can have the crow's feet at both ends. You understand? So if you have this at this end, the 3 ones here and then the 3 ones here, then it means many students can offer many elective courses at a time.
Yes, sir.
Yeah, so always your focus should be on the symbols. The 1, the 0, and then the crow's feet.
Yes,
The
sir.
crow's feet basically describes what it is. Rebecca, are you here?
Yes,
Yeah.
sir. No, Gabriel just posted something in the chat that's making me laugh. Can you have a look at it?
Hey, let me check it. Gabriel.
Yeah.
You are distracting the ladies at the back end.
Gabriel is causing
I want them
confusion.
to participate. So if you can use that example.
I should use the ladies example.
No, the female and male.
So many female to one male.
Yes.
Do you have money in your pocket?
Is there money? Yeah, so we
Okay,
can
so-
have males here and then female, and then we can have 0, 1, and then 1 male,
1-1.
or 1, 1, or
Yeah.
1 male.
No, it's not possible.
Yes, sir.
So we can have 1 female to 1 man, or no man at all,
Okay.
and then we
Ah,
can
Yes,
have
sir.
1 man,
1 female.
one male to 1 female, or many females.
Yes.
And so you can have
1 man,
1
more
female,
female.
side chicks.
many female,
1
many
female,
males,
many men. Yes.
many men. We can also have that. That 1 female is to many men at a point.
Yeah, that's what we want.
That's what you want.
That one, no money.
and then one
any-
male to many
one male-
females.
1 male to many females to time.
Yes.
That one, there is money
That one is
involved.
perfect. That one is perfect.
Yes.
That one is perfect.
That-
One
yeah.
to, one
The
to
one
many
with many
females.
females, there is money involved. But the one
And
with
many male to 1 female.
many
There. That
men.
one there, it's a trouble.
Debt.
They can somehow manage it.
They will manage.
Yes.
All right. So we have the last one. I think that will be the last one. They will end. So many to many relationship.
Uh-huh.
That is where we have student tutor. So here we can replace student with male, and then replace tutor with what? Female. And then we can get our class. So each tutor teaches 1 or many courses. So each female dates 1 or many men.
Or 20 boys.
Yes. Each male dates 1 or many women. That is also another possibility. Yes, and so that is it. So that's basically some of the examples. In essence, we can easily have that, and then we can have that relationship nicely. Female, so you see, Gabby has given us the relationship that exists.
Yes, sir.
But so he
Sometimes-
really seems interested in this particular example.
Who? Me
Yeah,
or
That
this
Gabriel.
one there is too
Gabriel.
equal. We want the other one.
he wants the ones that the women can be involved. You see, you guys were getting quiet, and the moment I sense that the ladies are becoming quiet, it means they are confused. You see, on this earth, they are the only people God created confusion for. Every second they are
Oh.
confused. Hey,
Oh,
women,
we beg.
they are aware, pa,
Sir,
but
it's
they'll
not
tell
like
you
that.
I'm
Sir, it's
confused.
not like that. It's not like that, sir. That's the confusion there is there.
A cabifi.
They are aware,
Come
pa,
on now,
but they'll
sir.
tell you I'm even confused. I don't even know what to say. I'm even confused. Hey. And so I did one cover by you. All right, so that is basically the different cardinalities and the what happens within them. So we will end here since our time is up, and then we will continue. So you can continue to read. When you meet during your group discussions, you can discuss and then finish it up, so that when we meet next week, we will just wrap up and then finish it. All right. So thank you very much for your time.
The
Yes.
the
questions
the group
quickly.
the group assignment. The
Yeah.
one you say will present, that will make sense. You haven't sent it.
When we I'll send one of the. I'll open it up. I'm looking at which
Okay.
one. to have so that we can open it up and then
Please, with that one, make it
preparing.
one assignment to one group like that. Nah.
Okay, so I should give topics to the 5 groups are a lot too.
Okay.
But he said he will
Okay.
give us topics so that we'll do presentation
Yes, so
next week.
maybe so maybe I'll list the topics and then you have it. But you see, all I wanted, or maybe I'll even have the slides still open. So maybe one group will still have the input and output as a topic.
Yes,
One
sir.
group will have e-commerce as a topic. Another group will have e-business. Another group will have security, ethical and security. And then another group will have global IT management as a topic. And then the 5 group you
Please,
yes.
please, with all these topics you are mentioning, do you have it on the LMS?
It's in the textbook. It will be in our textbook. So that one you have to prepare your own slides. I won't give you the slides. You prepare your own slides from the textbook. So I'll list the topics and then I'll send to Gabriel and then Joseph. Then you can share with you. So you go through the textbook, the chapter, and then you just prepare your own slides. Maybe 1
Yes,
to
sir.
15 slides be. So when we meet, the moment we get to class, we start. Group 1 will present on their topic. Group 2 will present. We will finish with the presentations and then we'll close. I
Yes,
think that
sir.
will be better.
Please let's do fair on the topic sharing. So maybe you can do that. You have the group, so you can
Yes,
share. And then,
I will just share. I will indicate 1 belongs to group 1. Group 2
okay.
belongs to group 2.
Yeah, they will fight over it.
No. So whatever I send, that is the group list. We won't change it. Group 1. As
Okay.
I said, group 1 will be the hardware, the software we did. They will prepare their own slides again and then come and present on that.
Okay.
And then the other topic will come in.
Okay.
All right. Thank you very much for your time. So I'll do that and then
Thank
share
you,
with
sir.
you. And then you have to check the textbook. It's in the textbook. If it's not there, you let me know. If there's any chapter that's not in the textbook, or I'll post another textbook. I'll check which one is there and then I'll add another one. So you can
Yes, sir.
all the topics. All right. So enjoy the rest of the day
All
and
right,
the
same,
rest of your
same, sir.
lectures. Right. So we will meet again, God
All
willing,
right, thank you too.
next weekend.
Thank you so much.
You're all welcome. All right.
Yes, sir. Hey, Samaba.